this strategy, as you see, the emboss voltage, the green phasor, will move progressively to its default value. Also, the control scheme is depicted, which is based on voltage current control scheme. The outer loop controls the voltage, and the inner loop controls the current. As you see, the short circuit current is effectively limited to 1 per unit. The emboss voltage is fully restored. But regarding the DC link voltage, because the DVR is controlled as an impedance, it absorbs power during short circuit fault current limiting function, so the DC link increases, which could be a matter of concern. A solution could be a dissipative strategy in order to limit this voltage increment. Controlling the DVR as an active inductance would ensure the zero real power absorption during fault current limiting function. For this purpose, the strategy that was proposed in the literature is based on constant active reactance using flux charge control scheme. The problem of this strategy is that, again, high ratio of X over R in the faulted feeder, which results in a slow decaying DC current component. Anyway, the AC component is effectively limited. For solving this problem, I have proposed this strategy, which is based on variable active reactance using voltage current control scheme. This strategy is based on increasing the voltage of a DVR in a ramp form instead of a step injection. Also, it should be noted that even during pure active inductance injection, DC link voltage would drop because of DVR losses. In order to avoid this drop and have a constant DC link voltage, the phase of the injection voltage is supposed to be constructed using a DC link voltage controller. You see, the line current is successfully limited to 1 per unit with fast decaying DC current component. The emboss voltage is restored fully, and the DC link voltage is kept almost constant. Conclusions. DVR is an effective device in order to mitigate voltage dips. The main drawback is complexity of protection during downstream fault. Among the passive strategies, the merged one is the effective one because it successfully limits the short circuit current and avoid interfering with upstream circuit breaker. Among the active strategies, the variable active reactance using voltage current control scheme can successfully limit the short circuit current to 1 per unit and have a fast decaying DC current component, and also ensure zero real power absorption. But the main drawback is the requirement for implementing a communication channel between the DVR and upstream circuit breaker. Thank you for your attention.
Okay, I have a question regarding communication channel. Between the circuit breaker and the disposer can be a limit, okay, you underline this. How can you use active strategy to overcome this limit and also to limit the switching capacity of the circuit breaker?
You mean how we can design the communication channel, or?
Yeah, how can you overcome the limit imposed by the communication channel between the using an active strategy?
In fact, this is the this is a new suggestion in the field of dynamic voltage restorer, and it hasn't still applied in any case. But because the DVR is immediately, in some cases, immediately after the circuit breaker, so implementing a communication channel for a very short distance could be an option, because in some cases the distance is short. So even with the cable communication channel, it can be implemented.
Okay, so you analyze this also from the actual state of art about this?
Yes.
Thank you. Are there any other questions? Thank you. You have to sign. So now, Komaye, Rami.